Good morning. I welcome you all for this session. I am Dr. Manjusha, and today we can discuss about the analog to digital converter. So in day-to-day life, all the real-time parameters are analog in nature. We can see the parameters such as temperature, pressure, speed, velocity, mass, etc. The easier technique for reading the data is digital. So all the communication and electronic applications are nowadays migrating to digital techniques. Analog to digital converter is a device that bridges between analog input and the digital output. The analog input is either voltage or current that has to be converted using a transducer, and that transducer output is given to an analog to digital converter by which the digital data can be read. So all the real-time parameters can be read using the digital signal via digital signal. This is a simple block diagram of an analog to digital converter in which we are having two signal. One is start of conversion and other is end of conversion. When the input is given, analog input is given to an analog to digital converter, after getting a start of conversion signal, it starts its conversion, and when receives an end of conversion signal, it stops its conversion. Whatever the output that has to obtained at that particular time will be displayed in the as the digital output. Mainly we are having three types of analog to digital converter: for flash type analog to digital converter, successive approximation type, and the integrating type analog to digital converter. First, among the three type of converter, flash type analog to digital converter is the fastest converter. The word flash meant that speed, but it is an expensive one. The flash type analog to converter consists of 2 power n minus 1 comparators, where n is equal to 3. When we are using a 3-bit output, we are considering a 3-bit output, we will be having 2 power n minus 1 comparator, that is 7 comparators plus 1, 7 plus 1 comparator, where the bottom one is the reference comparator. So all the let's see it in this diagram. We are having totally 8 comparators ranging from 0 to 7, so by which is given to an 8 to 3 line priority encoder. Hope you know that priority encoder is priority is given to the highest bit, that is x7, and the least priority is given to x0. For each and every comparator, two inputs are given. One is the reference signal, which is a known value, and the other is an analog input, that is an unknown value. So these two inputs are given to all the 8 comparators. So here the reference signal is given to the inverting terminal of all the comparators, and the analog input is given to the non-inverting terminal of all the 8 comparators. Let's assume a value, that is the analog input ranges from 0 to VR by 8. The output of the bottom comparator, which is x0 alone, will be high, which makes your output as 1 followed by 7 zeros. So that is given to an encoder by which the output will be zeros. That's y2, y1, y0 will be 0. Here, when the input lies between 0 to VR by 8, x0 comparator output will be high, which makes your output 0, 0, 0. And next, when the analog input lies between VR by 8 to VR by 4, the output lower two comparators, one x1 and x0, will be high. This data is given to a 8 to 3 line priority encoder, in which the priority is given to x1. So the output will be 1, that is 0, 0, 1. And next, the input goes on increasing, which where output is 1, 1, 1, that is x2 1, x1 1, and x0 1. Here the preference is given to x2, which makes your output 0, 1, 2. This is how the output goes on increasing. So since the values of analog input is varying in nature, accordingly the encoder output will also ranges. So here we are having only 3 bit ranging 0, 0, 0 to 1, 1, 1. The comparators compares the unknown value with a known value, which makes the comparator outputs on or off. Now, the greater advantage of this flash type analog to digital converter is its speed. The speed can be range of 100 nanoseconds or even less. Yeah, the only drawback of this comparator is its count of comparators. When the bit increases, accordingly the comparator count will also get doubles. The priority encoder becomes more complex as the value of n, that is number of bit, increases. Next, second type of analog to digital converter is successive approximation type converter. So it uses the principle of finding an unknown weight with the help of a known weight. So it is a simple comparison method. So each and every time the unknown value is compared with a known value, and when both the values become equal, the conversion will be entered, and that particular value will be displayed in the digital display. In this type of conversion, it has a 8-bit successive approximation register. Here this is a successive approximation register which has 8 out bit, that is Q7 to Q0. Initially it is set as 10000000, that is given to a digital to analog converter, which is considered as a known value. And next, the unknown analog input is given to the non-inverting terminal of comparators. These two values are compared and the output is given to a successive approximation register. So if it is not equal, the Q7 will be turned off. That means the given input voltage is less than the reference signal, means it is turned off. Q7 is turned off, Q6 will be enabled, and the remaining values remains as 0 itself. And now this particular digital value is again converted to analog, and further it is compared. So this comparison will be goes on continuing until these two values will become equal. Once both the values are equal, we can find out the output equivalent to an analog input. That is done by means of a conversion complete signal. So once it is completed, that particular value is the digital data equivalent to the analog signal. That is done by means of a successive approximation type analog to digital converter. So here this meant that the conversion is complete by the array of the SAR, which also acts as the enable line for the 8-bit latch. So this is the main advantages of a successive approximation type analog to digital converter, in which we are having only one comparator that is independent of the number of bits. So it is faster than dual slope analog to digital converter and with a higher resolution than flash type. Here the conversion process lies between start of conversion signal and end of conversion signal. So here the drawback of this successive approximation, it is slow speed. So here we have a number of clock cycles to find the correct data, so the speed will be slow. The input holding time is high and it has a medium accuracy. And the third type of analog to digital converter is an integrating type analog to digital converter. The same comparison method is done here. So a known value, which is a ramp signal generated by a ramp generator, that is given to compared with an unknown analog input. So here having a ramp generator, that is activated a timing and control unit, and next AND gate that decides the conversion time, that that decides the conversion complete time. Here ramp generator output, that is a known value, and then unknown analog input is given to a comparator. So the comparator compares both the values, and based on the output of this comparator, the AND gate will continue or complete the conversion. At the time of conversion, whatever the data will be having in this counter will be displayed as the displayed in this display, LED display. Here ramp generator produces a ramp signal that goes on increasing for each and every 1 milliseconds of time. So it is explained here. A unknown analog input voltage is given to the non-inverting terminal of comparator. A ramp input is given to a inverting terminal of comparator. The comparator compares both the ramp signal and the unknown value, and when VED is compared with 0 volt, which switches on the comparator, and that allows the clock input to pass through the AND gate, and the counter starts counting. The disadvantage of this integrating type analog to digital converter is its error. So since there is a change in the component values, it induces an error. Also the error can be occurred by the drift in clock frequency. The conversion or the time is maximum when the magnitude of the analog input is maximum. It means the conversion time will be elongated for the because of the higher magnitude. There is a comparison, it goes on increasing by 1 volt in 1 millisecond of time, so the number of comparison will be higher, which takes a longer time. As the drawback of this integrating type analog to digital converter. So in this video we have discussed about the three type of analog to digital converter. One is a flash type, it's a fastest type of conversion. Second one is successive approximation type, which includes a single comparator. And the third one is the integrating type comparator, that's the comparison of an analog voltage with the non ramp generator voltage. Thank you.